Hello everybody and welcome to my fifth video on my channel. For this one I will be going over session 1 out of 8 sessions that I will be doing, and each session has a couple of topics that we will cover. The sessions will hopefully be helpful, and it will go over some basic things you need to know about math and the basic skills, and some of them might be new. The first one is 1-1, which is types of numbers. So the first type of numbers are natural numbers, and those are those are all the numbers that are not negative and doesn't include zero. So 1, 2, 3, 4, 5, 6, and then so on. So it doesn't get less, but it goes more from here. Whole numbers are or just natural numbers, but with zero. So whole numbers include zero. 0, 1, 2, 3, 4, 5, 6, and so on. Odd numbers, um, basically are all the numbers that are not even numbers. That would be 1, 3, 5, and 7, and 9, and 11. As you see, the odd numbers rotate, so it goes 1 is odd, then 2 is even, so you can skip that for odd, and then 3 is odd, then the next number 4 is even, so it's not that, and then 5 is next, so that's odd. So even numbers, basically what are not odd numbers: 2, 4, 6, 8, 10, and so on. So you can use the trick about just the numbers rotating, and remember, but you're gonna have to know that zero is the first even number that does not include negative, and then 1 is the first odd number. So yeah, negative numbers are just natural numbers with a negative sign in front of it, and this is the negative sign. And if the number after the negative sign is smaller, that makes the number larger. So -1 is greater than all of these next values, and so on. Integers. Integers is the combination of whole numbers and negative numbers. So that would be -2, -1, 0, 1, 2, and so on. Now, rational numbers and irrational numbers are tough. So rational numbers can be written as a fraction or decimal. So 2 would be rational because it can be written as 2 over 1. 2.25 is rational because it's a decimal. 2.5 is rational because it's a fraction, and then so on from here. Irrational numbers cannot be written as a fraction or a decimal. So that would include, for example, pi. You can maybe search up pi later, but pi basically goes on for 3.14 and then, oh sorry, I did a comma, 3.14 and then goes on forever, and there's no fraction. There are other decimals that go on forever, such as, I'm just going to put this in parentheses, 0.66, 0.6666, and then it keeps on going. But this is not irrational because it can be written as the fraction 2 over 3. So this is the first lesson in session 1. On to lesson 2. 1-2. Properties of addition and multiplication. So the first property is the commutative property of addition, which states the way the numbers are ordered does not matter. So an example of this would be 2 plus 3 equals 3 plus 2. As you can see, the only difference is numbers altered the order, but you know that these are both, so these are both equal to 5. Okay, so commutative property of multiplication. This is the same thing, though the way the numbers are ordered does not matter, but with multiplication. So 2 times 3 equals 3 times 2. As you know, these are both equal to 6. Okay, now we have the associative property of addition. This one states the way the numbers are grouped does not matter. So when I say group, when it says grouped, I think of parentheses. So, for example, 3 3 plus 4 plus 5 equals 3 plus 4 plus 5. And you know that these are both equal to 12. Now, same thing for multiplication. The way the numbers are grouped does not matter. So we can use the same example. 3 times 4 times 5 equals equals 3 times 4 times 5. So in this case, they are both equal to 60. Okay, next we have the identity property of addition. This one is not, for this one the multiplication is not exactly the same. So this one is a little more complicated, but still pretty easy. So the identity property of addition states when a number is added to 0, the number remains the same. So an example of this would be 123 plus 0 equals the same number, 123. For identity, it's not when it's multiplied by 0. That would be the 0 property of multiplication, but it's actually when a number is multiplied by 1, the number remains the same. So 123 times 1 equals 123. The inverse property of addition states that when a number is multiplied by its opposite, the answer is 1. So opposite means like if 4, like the opposite of 4 would be the negative number, which is negative 4, and the opposite of negative 4 is 4. So 4 plus negative 4 according to the property is 1. Now the inverse property is also of multiplication is different than the inverse property of addition. This one states when a number is multiplied by its not opposite but reciprocal, the answer is 1. So reciprocal is basically the numbers written in fraction form, and then the numerator, which is the top number, and the denominator, which is the bottom number, are flipped. So let's use 4 over 4 thirds. Then when it's multiplied with its reciprocal, when we flip it, 3/4, it is equal to 1. Now, 0 property of multiplication states when a number is multiplied by 0, the answer is 0. So 1,234 times 0 equals 0. Now, this does not, like, for what, as we learned in the identity property of addition, when the number is added with 0, it just equals the same number. And then since the identity property of multiplication is 1, the 0 property only works for multiplication because we already have the identity when it's added 0. Okay, now the distributive property, this is like the more complicated one, and you can like use the breakdown method of the distributive, which is like 4, then this parenthesis means times. Then we can pick a big number, 58. Then you can write this one in the breakdown method as 4, and when you break it down, 50 plus 8. Then the distributive property states that you can write this as 4 times 50 plus 4 times 8, which makes it much easier because these are both, you can do it in your head rather than have to write down 4 times 58. and we get this is 200 plus 32. That is 232. So now there's another thing of this, which is you can use it to combine. So pretend we have 4 and then 4 times 7 minus 4 times 6. We can combine this and make it 4 times 7 minus 6. That equals 4 times 1, and that equals 4. So this is just combining what we did over here. But the main thing you have to learn is probably making this, being able to form this 4 times 50 plus 8 into this. So yeah. So now we're going to do some practice of what we learned. Practice. Which property is shown? So you can pause the video and do up to here. You can do all these practice problems. And then once you're done, just unpause the video and I will move on. Okay. Hopefully you paused the video and checked, but I'll go over the answers. So this one, we can see that it's just the order that has changed. 8 and then 8 plus 7 plus 6, and then they're the same numbers, meaning it has to be commutative. Commutative, and then property of, then it's not multiplication because there's an addition sign, so it would be addition. So hopefully you got that correct. Let's go to the next one. So this one, if you solved it, then you should have gotten the associative property because nothing's changed except the parentheses are around different numbers, meaning the way it's grouped has changed, and that's what the associative says. The way the numbers are grouped does not matter. So associative property of, and then this is also addition because of the addition signs. Now let's go on to this one. Well, when you pause the video and solved, you can see that the number is in the reciprocal form of this, and there's also a multiplication sign, meaning it has to be the inverse property of multiplication, because there's two reasons why it's multiplication. Obviously the multiplication sign, and it's the reciprocal, not the opposite. Now the next one is, this one is the commutative because the order is changed, property, and then this one has a multiplication sign, so multiplication. Now, the next one was the harder practice. If you haven't paused the video yet and just solved the first part, you can pause the video now and do this. But if you already did, I will be going over it now. So, yeah. So this one, use the distributive property to solve. So the first step is, we don't have to combine. We can either combine it or just use, or we can form this part 4 times 50 the way we did this, and I'll show you both. So when you combined it, you should get 5 times 11, and you can do this in your head and get 55. Otherwise, you can just, and then, or you can do 5 times 7, because when it's in parentheses, 5 goes to this, and 5 goes to the 4. So, yeah. 5 times 7 plus, still has to go to the 4, 5 times 4. And then you would get equals 35 plus 20 equals 55. Same thing, let's do both methods. Right. So for this one, it would be 3 times, when you add it, 9, 15. And if you can do this in your head, then good job. But if not, the answer would have been 45. So, or you can do 3 times 4 plus 3 times 5 plus 3 times 6, and this is equal to 12 plus 15 plus 18, which is equal to 17 plus 18, which is equal to finally, oh wait, sorry, I mistyped, 27 plus 18, which is finally equal to 45. Okay, that was some tough work, but we are finally done with the 1-2. Now on to 1-3. Order of operations. So we have this acronym here called PEMDAS, but some people like to call it please excuse my dear Aunt Sally. So PEMDAS stands for parentheses. I always spell this wrong. Yes. Parentheses, exponents, multiplication, division, addition, and subtraction. Okay, so order of operations is the order in which you solve an equation. So first, if you see a problem I'll do the first practice problem with you. If you see this problem, your first instinct would to be solve what's on the left side in this, but that is wrong because first on the list is parentheses. And by the way, multiplication and division are equal to. So I'm going to make it easier and put them on the same thing. So you just do whichever is on the leftmost side. Same thing for addition and subtraction. So yeah, actually I shall not be doing the first one. I was just using that as an example. So you would first, a hint, you have to solve this first because it comes first. Then check exponents, this, and yeah. You can pause the video and solve all the practice problems. Once you're done, you can unpause it and I'll check if you're correct. Okay, hopefully you paused the video, and if not, well then do it now. I will now be solving this. So first we have to do the parentheses, so we can leave this the same. Minus the parentheses, you obviously know 3 plus 2 is 5. So 5 and times 6. Now we have to check any exponents. No exponents. Any multiplication or division? Well, there's no division, just multiplication. So we solve what's on the leftmost side, which is this thing. 4 times 5. So we can do next is equal to, I'm going to combine this. This is equal to, 4 times 5 is 20, minus 5 times 6. Okay, next step, we solve what's over here. Because multiplication comes before subtraction. So this is equal to 20 minus 30. Now, if you don't know this, you're probably thinking, wait, 20 is smaller than 30. So how do we subtract this? This is when negative numbers come in handy. This answer will be a negative number. So if you don't know this, this is equal to negative 10. So the way to solve when you have the first number smaller is you have to take the first number and just switch it, and it would be 30 then. It would be 30 minus 20, and that equals 10. But since this number was first, you have to add a negative sign to this, meaning it would be negative 10. So this would be negative 10. Okay, so the answer to this one is negative 10. Next one, let's see. Is there any parentheses? Yes, I see one right over there. So we can leave this the same. 8 times 9 plus 4 divided by 22. And then we can do plus 14. Next step is there any multiplication or division? Well, I see both. I see multiplication and division. So right over here is multiplication. So this would be 72 plus 4 divided by 22 plus 14. The reason we did this first was because it was on the leftmost side. Now, here's the hard part. You have to do this and divide it. But for this one, we are going to leave it as a fraction, which is a trick I like to use. And so we can just add this all. So this would be, so as stated in the commutative property, we can change the order of the numbers. So we can change this to be 72 plus 14 plus 4 divided by 22. So now we can just leave this as a fraction. So pretend this is not a division thing. Pretend it's just a fraction. So that means it's already solved, meaning we can move on to the addition. 72 plus 14, if you solve it, is 86. And then we have this 4 over 22. So our answer would just be 86 and 4 over 22. So yeah, this one was a pretty tricky one, but this is the answer. Hope you got it. So next one, let's see. We have parentheses 20 plus 22, and that is 42. So 42 divided by 2 plus 5 minus 4 times 2. So now, do we have division or multiplication? We don't have exponents, so we got to go on to multiplication and division. I see both, but we're going to do this because it's on the leftmost side. So 42 divided by 2 would be 21. So this is equal to 21 plus 5 minus 4 times 2. So now we have this multiplication at the end, which I mentioned earlier. Now we have to solve that. So it would be 21 plus 5 minus 8. Okay, next one, we have addition and subtraction left to right. So 21 plus 5 equals 26. And then minus 8, and we get our final answer as 18. So the first two, if you didn't get all of them correct, hopefully you got the number 1 and number 3 correct using what we learned. Now, we're going to go to 1-4, divisibility rules. So I'm going to be filling these in. The divisibility rule, this is very simple, like as we learned earlier about this, the divisibility rule of 1 is it must be a natural number. So, must be a natural number. The divisibility rule of 2 is must be an even number. You guys must be thinking, what in the world is divisibility? Well, if you're not, then congratulations. Well, divisibility means like it can go even into a number without having a decimal or fraction at the end. Like 4 divided by 2 is 2, and it has no decimals at the end or a remainder. So it must be an even number, as we learned over here. Even numbers. So yeah, let's go on. 3. When you add the digits of a number, the result must be divisible by 3. So you're still going to have to know a few things for this one. You're going to have to know a few numbers that are divisible by 3. So if you get like 999, when you add those, you get 27. You're going to have to know that 27 divided by 3 is a whole number or a natural number with no decimal. And you have to know 27 divided by 3 is, it's 9. So that means 999 is divisible. 3 is divisible. Yeah, 999 is divisible by 3. So 4. The last 2 digits of the number must be divisible by 4. So you're going to have to know every single number 4 is divisible by in 1 in 0 through 99, because those are all 2-digit numbers, and the rule wouldn't really, well, it would work, but it would not really help. But it will help when you have bigger numbers. So like if you have 9,900,084. So it's such a big number. I don't even know if you know what I think, but hopefully you heard the last 2 ones. I said 84. And 84 is divisible by 4 because 40 because 20 because 21 times 4 equals 84. So yeah. So for 5 is the number must end in 0 or 5. So this is a straightforward divisibility rule. You just have to know 0 or 5. Okay, 6. 6 is the number must be divisible by 2 or 3. So you must check using these two divisibility rules. So 2 is the combined of divisibility rule of 2 and 3. Sorry, I put or? It's and. 7. So 7 is double the last digit of the number and subtract it from the rest of the numbers. So like the last digit of, let's take for example 842. Double the last digit of the number. You would get, okay, 842, 2 times 2 is 4. So then you subtract it from the rest of the number. 84 divided by minus 4 is 80. And if you know this, 80 is not divisible by 7, meaning 842 is not divisible by 7. Okay, 8. The divisibility rule of 8 is the last 3 digits of the number must be divisible by 8. So this one is probably only like, if you have a big number, you just have to divide it by the 3. You don't really have to memorize it. Maybe you can just use the standard way to do it. So yeah, no, 9. This one's the same as 3, except instead of it must be divisible by 3, it obviously must be divisible by 9. So the sum of the digits of the number must be divisible by 9. Okay, now we're going to do 10. This is like 5, except it can't end in 5. It must end it in 0. The number must end in 0. Now for 11, this one has a complicated one, sort of like 7's is a little complicated. So, let's take, for example, the number. The switching means like, if the number is 1, 2, 3, so I'm going to put this in parentheses, 1, 2, 3, the switch number, meaning like, it would rotate, sort of like even, odd. This one goes first number. The first, sorry, I have here's a simpler way to write it. The first, third, fifth, and so on amount, and fifth, so on digits, subtract, and then subtracted from the second, fourth, sixth, and so on. So the first, third, fifth digits subtracted from the second, fourth, sixth digits must have a result divisible by 11. So take for example the first and third. Pretend this is only a 3-digit number. So pretend that the number is it's 209. So 209 is divisible by 11, because when you add the first and third, 2 plus 9, that is 11, and then 2 is 0, so 11 minus 0 is just 11, and 11 obviously is divisible by 11. And the divisibility rule of 12 is the numbers must be divisible by 3 and 4. So that's all the divisibility rules from the numbers 1 through 12. So now you can do these practice problems, pause the video, and you can check if you're, and then once you're done, unpause. So after, hopefully you paused it, now let's check. Is 890 divisible by 6? Let's scroll up and see the divisibility rule. The number must be divisible by 2 and 3. So let's check. Is it divisible by 2? Yes, it is, because it is even. That means it's divisible by 2. Now, the next thing is it must be divisible by 3. So let's add. 8 plus 9 plus 0 is 17. So that, and 17 is not divisible by 3, so that means no. Now is 8 is 890,834 divisible by 4. We just have to check the last two digits. So 34. Let's see. Is 34 divisible by 4? No. So that means the answer is no. I don't know why there's a question mark. Okay. Next is 325,049 divisible by 9. Okay, let's add this. So 3 plus 2 is 5. 5 plus 5 is 10. 10 plus 0 is 0. 10 plus 4 is 14. And 14 plus 9 is 23. And 23 is not divisible by 9. So every single one of these is no. So that is all for session 1. We went over types of numbers, properties of addition and multiplication, order of operations, and divisibility rules. So I hope session 1 was useful and will come in handy later. So see you in the next session.